Buonasera e benvenuti a tutti a questo nuovo appuntamento con i Meetup Agritech Online Edition di Codemotion. Questa sera siamo con la community Deep Learning Italia. E qui insieme a me c'è Andrea Gatto e Thomas Shalom, che a breve lascerò la parola. Prima di lasciarvi al Meetup, io vi ruberò giusto pochi minuti per raccontare cosa sono gli Agritech per chi non ci conosce. Gli Agritech è un circuito di eventi ideato da Codemotion e realizzato insieme alle tech community. Lo scopo è quello di divulgare la conoscenza, la tecnologia e l'innovazione. Qui a video, per restare informati, ovviamente qui a video vedete i nostri canali, abbiamo il nostro canale Telegram, e il nostro dev calendar dove potete trovare tutti gli eventi e abbiamo anche il nostro gruppo Facebook, Codemotion Tech Community, dove ovviamente vi invito a registrarvi per restare aggiornati e partecipare oltre a fuori diciamo da questi eventi, fuori dai meetup, di partecipare alle nostre iniziative. Vi segnalo i prossimi eventi in calendario, ovviamente andando sul sito community.codemotion.com potete vedere tutti gli eventi di questa community o di altre community e quindi registrarvi. Vi ricordo che il 23, il 24 e il 25 di marzo, quindi a brevissimo, ci sarà la conferenza di Codemotion. Come sapete, da anni Codemotion fa le conferenze e ovviamente in questo periodo di Covid siamo costretti a trasferirci online, ma continuiamo con le nostre conferenze. La conferenza ovviamente è una conferenza per sviluppatori fatta da sviluppatori e toccherà, come potete vedere in questa slide, toccherà 5 temi, quindi avremo dal back-end al front-end all'intelligenza artificiale e tantissime altre cose. Ovviamente vi ricordo anche il biglietto gratuito, che adesso poi scriverò in chat così per tutti, così è più facile raggiungere il link. Vi raccomando, è disponibile per ancora pochissimo tempo, quindi registratevi e approfittate per avere il biglietto premium che vi darà diritto ad alcuni benefit. Detto questo, vi ricordo ancora che il 18 di marzo alle ore 17 ci sarà una nuova iniziativa, un nuovo format di Codemotion, il DevCast, dove verranno affrontati da dei super speakers dei temi sempre legati alla tecnologia, quindi non mancate. E inoltre ci sarà un altro format, un nuovo format di Codemotion che è il Codemotion News, che è appunto un TG dove verranno elencate alcune pillole sempre legate alla tecnologia. E inoltre vi ricordo il 13 di aprile un panel organizzato dalla community di Codemotion, e questo qua è il secondo episodio legato alle performance delle vostre applicazioni, quindi non mancate. Detto questo, lascio la parola ad Andrea. Noi ci vediamo dopo per i saluti.
Okay, so let's switch to English. Good evening and welcome everyone to today's meetup. Just a quick introduction for those of you who don't know Deep Learning Italia. Deep Learning Italia is a community focused on, guess what, deep learning. So if you're interested in deep learning, machine learning, data science, and so on, I invite you to subscribe to the Meetup page in order to stay up to date with the upcoming talks, events, and so on. So that being said, I'm very happy to introduce today's speaker, Thomas Shalom. Thomas is a partner of the startup Registrati, which is a Paris-based company focused on natural language processing. He's also a PhD student at Sorbonne University, and his research focuses on natural language generation. So I think that's it for the introduction. Concerning questions, we'll have a Q&A session after the talk, so feel free to write your questions in the chat, or if you wish to speak, you can raise your hand during the Q&A session. So that's it. Thanks a lot, Thomas, for being with us, and thanks everyone for having joined us. And yeah, Thomas, the screen is yours.
Thank you very much, Andrea, for the introduction. Hi, everyone. So yeah, as you mentioned, the talk will be about natural language generation from the training, inference time, and then how to evaluate it, with a focus on the recent research we conducted recently. Is it fine? Do you see my screen?
Yes, yes, we can.
Okay, sorry.
Perfect. So, yeah, natural language generation encompasses tasks such as machine translation, chit-chat dialogue, or abstractive summarization. In this talk, I will first discuss the standard practices that we currently are doing for the state of the art. So training, inference, and evaluation. And then I will discuss the limitations and how to go beyond these limitations to get a better generation. Also, beyond English only generation, you might be aware that most of the work are done in English and English models are working better. And how to get a better evaluation of our systems, which is still an open research question. So what about the current standard for the training pattern? As you may know, we mainly use now sequence-to-sequence models, noticeably the transformers. We used to pre-train them in a self-supervised stage. For instance, you have T5 or BART. It's mostly like BERT for those who are not familiar with them. And we fine-tune them on a large corpus of data where we try to mass some words and we try to predict them with the model. And so this is why it is called self-supervision. And then you have the fine-tuning stage via teacher forcing, where you basically train the model directly on the downstream tasks you are interested in. For instance, abstractive summarization or machine translation. So what is teacher forcing? It's a maximum likelihood estimation on the ground truth. In other words, given an input X and the target sequence Y star composed of n tokens, what you want is to maximize the log probability of YT star, knowing X, the input, and all the previous tokens before T from Y1 till YT minus 1. And you want to maximize this probability. So let's take a concrete example. The ground truth here is two people running. You are at the training stage, you initiate the model with start of sentence. The model generates 2. It's cool because it corresponds actually to the ground truth. So you feed the model 2, and now the model generates birds. But wait, you cannot feed the model birds within teacher forcing algorithm. With teacher forcing algorithm, you will actually feed the ground truth token. So here, people. And so this way, you can condition the model on the ground truth, 2 people, to try to predict running. This is how teacher forcing is actually running. And this, you can consider this as the standard algorithm to train any sequence-to-sequence model. So what about inference time? So we still have the same sentence, 2 birds, 2 people are running. And so at inference time, you don't have access to the ground truth. It will be cheating. You don't know what is a reference, the human text. And in production, you won't have access at all to it, right? So actually, you feed the model with what it generated, here birds, and so you have 2 birds and not 2 people. And maybe the model will generate something like 2 birds are flying, which might be correct. But you see that basically there's a mismatch here between the training stage where you give to the model the ground truth and the inference time when it doesn't have access to it. And so actually if the model makes a mistake at training time, it's fine because you will replace with the ground truth. But conversely, at inference time, if the models make mistakes, they don't have access to the ground truth, and so they are exposed to their own mistakes. And this bias and this mismatch between training and inference time is called in the literature as the exposure bias, because the model was never exposed to their own mistakes during training. So this is one of the limitations for teacher forcing. And this is why sequence models are known to be subject to this bias. Also, one issue is that, if you think about it, they are trained on a single reference per example. Here, the previous example I display was about 2 people running. But maybe that 2 birds flying is also correct. And for instance, in summarization, you have many ways to write the same summary for the same article. And actually, we are forcing the model to learn only one exact same summary and not all the possible summary. So the model considers all the other possibilities as incorrect. And finally, which is kind of linked to what I just said, we are lacking a sequence level loss because the optimization is done at a token level, token by token. And this is noticeably why generated texts are known to be degenerate and prone to repetitions. Here, for instance, you have an example of the exposure bias in Professor Forcing paper in the handwriting task. I think it was from Sami Bengio or Yoshua Bengio, I don't know. And you can see that the model basically made a mistake at the middle of the generation, and it can never recover from this mistake. So now that I talked about training and inference time, let's discuss the current evaluation for these systems. I think that evaluation is something extremely valuable in AI in general, maybe beyond AI, because you need to evaluate the quality of a model in an automatic way to be able to measure the improvement. If you're not able to measure any improvement, it's really difficult to improve as a field. And right now, the current paradigm is n-gram-based metrics. You may have heard about rouge or bleu. You can consider them really, really close together in kind of similar metrics, honestly. The idea is extremely simple. You have the evaluated text, and on the other hand, the human reference text. And what you want is to compare these 2 texts. And so you are actually doing you are counting the overlap of n-grams of tokens between the human reference and the evaluated text. That's all. As I mentioned, so most of the datasets provide only one reference. For instance, in summarization, I will talk about that. There's a huge corpus called CNN Daily Mail for the CNN and Daily Mail newspaper, where you have paired an article, source document, and its human written summary, but there's only one human summary. And it's possible to write summary in very different ways that might be possible. And so what about synonyms? This matrix computes the correlation, the overlap between only one human reference. This is a big issue. So to go beyond that, you have also neural-based metrics. Here, for instance, the BERT score is the most famous one. It's working quite well for some tasks. But the idea here is basically to leverage on the BERT representations to go to, for instance, mitigate the issue with synonyms. And so if you have 2 tokens that share the same meaning, the idea is that they should share the same representation from BERT hidden state. And so we compute the co-similarity between the 2 representations. But still, this metric is based on at a token level, and there's a lot of limitations. So the first one is that it's not applicable for other languages. There's different morphological structures, like I know some papers, for instance, about Korean that show that rouge or bleu based on at token level, doesn't work very well for this language. And so it's not a universal metric. Also, it's poor accounting for the fluency or factual consistency. Like if you switch for Rouge, if you measure the overlap of 1 gram, so token, the unit will be token 1, and you switch all the tokens of the sentence, if all the tokens are still correct, you will maximize the metric. And this is not what we want. And same if you switch 2 dates, for instance, the factual consistency, which is something really important. We want the text that we generate to be really factual consistent with the source document, where either it is like, for summarization or for translation, you want to translate a sentence that is correct and doesn't destroy the meaning of the input, which could be done if you swap to dates or to percent sentence. These metrics will still have a really high score, but the meaning will be completely different. And that's a big issue. And as I already mentioned, one of the other limitations that these metrics are extremely greedy in terms of references. The intuition for here is, again, there are more than one output that could be correct. And as I will show you later, the correlation with respect to human judgment is decreasing significantly with respect to less and less references that we give to the metric. This is an issue when, with large-scale dataset that we get now, we have only one single reference for each example. So here is a paper from Salesforce last summer, where they conducted a really large study of evaluation on summarization on the CNN Daily Mail corpus that I mentioned before. And so you can see Rouge 1, Rouge L, which is for the longest common subsequence, Meteor, which is roughly similar, Bleu. Basically, Bleu is more precision-oriented with respect to Rouge, which is more recall-oriented, and BERT-gen. And so here it's for 4 different dimensions: consistency, coherence, fluency, and relevance. So, and the average. And so here, this is the percent coefficient, which is between 1 and 100. And you can see that it's extremely low, actually. It doesn't reflect well human judgment. But this is given 11 references. What happens when we give only 1 reference, which is actually the case in real life? And what you have to know is, for this paper, they have written additional 10 references. But in real life, when people are reporting results on the test set, it's always based on 1 reference. And this is more realistic. And you can see that the correlation is extremely low, like it's 0.1 basically, or 10 on 100. And it means that we cannot, with these metrics, assess properly what system is better than what other system. So now, beyond these limitations, let's first start with a better generation. So an alternative to teacher forcing will be to reward not with a local optimization at a token level, but with a reward for the entire sequence. It will mitigate the exposure bias. And this actually has been applied on machine translation from Marco Lorenzato, and on, I think he's at Facebook now, and on abstractive summarization from Romain Paulus from Salesforce. And so the former applied it with a reward based on Bleu, the later on summarization with Rouge, which are the metrics corresponding more to the task. But the idea is the same. You want to maximize Rouge or Bleu for your system. And actually, this leads to a large improvement for the metric, Rouge or Bleu. But the issue is that it comes at a cost for lower output quality. So, wait, what? we improve the quality of we improve the metric, but we get lower qualitative output, lower generation. What's the intuition here? So first of all, the metric is biased, and really too much biased. Given the correlation of 0.1, this is not surprising. Maybe with a perfect metric with correlation with 1 with respect to humans, it will work. And so here, basically, what the generator is doing, the neural models is taking advantage of the matrix weaknesses. Rouge and blue are imperfect, and the generator, via reinforcement, is able to get these weaknesses, improve the matrix, but not the quality of the output. It's like the generator becoming adversarial to the metric. So a natural alternative will be the GAN paradigm, generative adversarial network. And so here the metric will be a discriminator. So a discriminator is basically a classifier that tells you, is trying to detect if a text is written by a human or generated by a machine. And this will be a natural alternative, in my opinion, because here the discriminator is trained in pair with the generator. And so if the generator starts to become adversarial to the discriminator, the discriminator will fight back, because you can still fine-tune it during the training. And so both will improve together. But there's a nice paper, I think it was last year at ICLE, that shows that GAN, language GAN, are falling short. Few reasons about that, because this is something very specific to text, but text has a discrete nature compared to, as opposed to images, where pixel is continuous. The vocabulary is not continuous. And so here we use reinforcement learning to backpropagate the gradient, and it's much more unstable. But there's something really interesting. Okay, GANs are falling short, but still the discriminators, if you check the accuracy, they're extremely good. They detect if a text is written by human or made by machine with an accuracy higher than 90%. So the question here is, how can we leverage on this discriminator's performance to improve text generation? For this, we proposed last year at ICML the DAS, Discriminative Adversarial Search. The idea is very simple for those who are familiar with beam search. So in beam search, the algorithm basically generates few beams, and you select, you can have basically as much beams as your vocabulary, for something about 50,000. And you will select only the beams with the highest probability given by the generator. And your algorithm will basically over-optimize the argmax for the sequence. The intuition is that a greedy approach will select only the token with the highest probability, but maybe that next, for the second token, this will have a really low probability, while went, that had, I don't know, for instance, or spent, that had a lower probability than go, the second token my will actually get, so the product of the two will get a much higher probability than the probability following go. That's the intuition of beam search. And that's the main algorithm used in neural text generation. But the issue is that, so we have a probability given by a generator that are not perfect. They are known to generate text that are degenerate with repetitions. And on the other hand, we have a discriminator that is very accurate to detect if a text sounds human or machine-made. And so the idea is quite simple. Instead of using only the generator probability, we will refine the probabilities given by our discriminator. For instance, here, I go to 2. Maybe 2, the generator assessed the probability really high compared to I go to ICML. But the discriminator, if well trained, will detect that this doesn't sound at all human, and will lower. By refining the probability like that, you can re-rank the beams and put IGO2 to ICML, which sounds much more human, above IGO2 too. So it's kind of like we have now a second leg for our beam search, augmented by the discriminative adversarial search. We did some experiments on noticeably summarization. It worked quite well, but not that this could be applied to any sequential generation task, not only even text. For time series or I don't know what, you could leverage on that. And we also had a second mod, which I think is quite cool, called DAS-retrain. So how is the entire thing? First, we have a discriminator that is trained on the generator outputs, right? So you have training data. The generator was trained on the training data. On this training data, on the source, we generate now the outputs, the predicted sequences by our generator. And so you have, for each example, the human text and the generated one by the generator. This is the data we train our discriminator on, right? Now we plug, we have DAS, which is a combination of the generator and the discriminator. And so the generated sentences here will be improved when using the discriminator than the one generated only by the generator. The combination of the two, in other words, gives better outputs than only from the generator. And so we can generate new improved, thanks to the discriminator sequences, that we can use again as a new learning signal to fine-tune our discriminator and so on. And so you have a self-training scheme here by generating new improved sequences, fine-tuning against the discriminator, and so on, that leads to further improvements. But still there's one limitation in DAS, which is that the generator was considered as a black box, and we never fine-tune it in DAS. I mean, basically we train it once in train data, but then we only fine-tune a discriminator. The generator remains the same during the entire process. So the generator remains in its comfort zone. And to go a step further DAS, we will need to fine-tune it, which will basically lead to the GAN framework. And here the generator learns without suffering from teacher forcing limitations. The metric is learned again like the discriminator. So why GAN are falling short? That's a question we was wondering. And in our NeurIPS paper, we show that actually what we call as a phenomenon, the discriminator's no free lunch, that discriminator seems to be hyper-specialized. In other words, it seems that if you basically train the discriminator on the generator mode, okay, the discriminator is extremely good on this text. But if you show the discriminator another system or even another temperature, the Boltzmann temperature of a softmax when sampling the text, the discriminator will be completely lost as opposed to the generator. And so this is why we propose cold GANs, timing language GANs with cautious sampling strategies. The intuition here is that in all the GANs, in language GANs, they were via reinforcement learning, as I already mentioned. And this is done via the Williams reinforce algorithm, where we sample sequences at a temperature T equal 1, which is a default temperature. And this has been shown to sample some sequences that are unstructured. This is why at inference time, when we use beam search, it more or less corresponds to a temperature much lower, closer to 0. And so to stabilize the discriminator, what we need is actually that instead of sampling at a temperature t equal 1, we sample at t equal 0 during the training. It offers a much more structured sample. It stabilizes the discriminator because then here the discriminator will be accurate on it. And if you change too fast the generator, the discriminator will be lost and will output a wrong signal. And so doing that will allow to a smoother learning dynamic. And it actually leads to state-of-the-art results on the 3 generation tasks we tested it on, which are summarization, question generation, and unconditional text generation. So what about, so all these tasks I mentioned and all these works were done on datasets, mostly on English dataset. And I believe that, well, English, first of all, is not the only language, and it's quite the opposite, actually, spoken out of the world. And so we should make our model more inclusive and understand other languages than English. That's the first obvious reason. But also, I fear that using only English datasets, we might overfit English as a language in our models. So actually, there's quite a few datasets in natural language generation that are not in English, which is why we proposed MLSUM, which is the first multilingual natural language generation dataset. And I'm sorry, there's no Italian here, but so it includes German, French, Russian, Spanish, and Turkish languages with 1.5 million articles, which are in the CNN Daily Mail style. And what was really interesting in this paper is to see that TextRank, so for those who don't know, TextRank is an unsupervised algorithm standard. It's extractive on extractive summarization. Basically, the idea of TextRank is that it will it will weight all the sentences of a source document, and it will select in an unsupervised way the ones that are central to the source document and extract them. And TextRank is known to be a good baseline for summarization, and it's unsupervised. But what was very weird is actually that English seems really, and you can see that all the languages follow the same line, but English is extremely, it's an outlier here, and it's actually showing an overfitting for TextRank, which confirms the fear we had, and that it also gives strength to the motivation for not only English datasets. So in this paper, we also had to generate text, so in an abstractive way. And at this time, there was no abstractive multilingual models. I think that right now you have a BART NT5 multilingual, which are sequence to sequence. And so the only model that was available in a multilingual way was BERT multilingual. But BERT is known to be an encoder only, which means that you can use it for language understanding, like classification, but not an encoder decoder, so you cannot use it for generating text. Adapting it for other modes, like generation actually, would require some extensive pre-training. In UniLM, which was a Norris paper 2 years ago from Microsoft, they show state-of-the-art result on abstractive on generation, but it requires to adapt BERT with an extensive pre-training. And you can see the same for multimodality, aligning vision and text, for instance, visual BERT, which will require quite an extensive additional training stage after BERT. And actually, we show that you don't need that at all. We call it BERT-gen for BERT Generative, and we show that it enables both multimodal and multilingual generation without any additional pre-training. The only thing is that it requires a left-to-right mask to mask the past, because when you generate a text, you don't want to know the future. And we show that this way to frame BERT, you can plug it as it, and it can become a sequence to sequence, getting state-of-the-art results. We use that in MLSUM as a strong baseline to generate multilingual text. And in BERT can see out of the box, we also show that it can even be adapted in a multimodal way, quite interestingly. We tested it on visual question generation. So here the task is that given an image, you want to generate relevant questions. And so here's the image. And our BERT, basically, what is it? We have visual embeddings from a pre-trained CNN. It's like an embedding. And we consider them as tokens. And we map their hidden size to BERT hidden size. So with a linear layer, you cannot do it simpler than a linear layer. And here, the only thing we learn is this linear layer. And interestingly, it works extremely well. So this is done with the text. The one is generated with the text only, while the third is generated with the image plus the caption. And you can see that this multimodal generator allows to generate quite good questions, like what time is it? And its attention focus on the clock. And so again, this was done with BERT. You just plug a visual feature in it with a linear layer, and it works out of the box. So that's extremely interesting, I think, for future works to adapt models without any extensive training stage and adaptations. And so I will end the talk talking about how to get better evaluation beyond the bleu, rouge, or BERT score. So there's a new family of metrics based on question generation. For instance, so this is mostly a summarization metric for now. And so the question is, what will make a good summary? A text that is, okay, short, sure, but able to answer all the important questions from the source document. You have here, so a source document, your summarizer that generates a summary. To assess if the two texts contain the same kind of information, you can generate all the questions and ask them, so generate all the important questions on the original text, ask them on the summary, and conversely, to check if all the information are correct in the summary, generate all the questions on the summary, and ask them to the original text. So in SumAccurate MNLP 2 years ago, we basically did this. You have the source document, you generate questions, you ask them on the evaluated summary. This is kind of recall oriented because what matters also is to get all, so if there's an important information that is not contained in the summary, you will have a low score. Conversely, in Quags, Alex Wang presented the opposite metric, where you generate questions on the source document, on the summary, and you ask them on the source document. And this metric then is more precision oriented. If there's missing information, that's fine. But what you want is that all the information in your summary are correct with respect to the source document. So note that these two metrics are referenceless. You don't need a human reference, a human summary to compute the metric. And this is extremely interesting. So compared to what we showed before, remember that was on CNN Daily Mail with these 5 metrics, 11 references. You drop the score by 50% using only, which is realistic, 1 reference. So these two metrics are not really improving in average, and they are far from, they're okay and they're referenceless, but still they are not improving quite a lot. what is interesting is that you can see that the consistency, which are all the information in the summary correct with respect to the source document? It's captured by quals, it's precision oriented, and conversely, the relevance is much more. So again, this is a person coefficient correlation with respect to humans. And so for the relevance, it's much more captured by SumAccurate, which is recall oriented. And in a paper that will be, we will put on archive actually this week, it was rejected at NACL. So we actually combine both the precision and the recall, and to take into account both. And we added a component here because here we said our previous matrix was recall oriented, but we had no way at the time to select what is an important question and what is a question asking about anecdotal facts. We had no way. And so in the paper, we added a classifier that learns what is an important question and what is not, which is a way to filter the questions and to improve so the metric, the recall-oriented metric. And so again, this allows to unify the two approaches, integrate this query weighter, and it's still referenceless. And so here are the scores. I'm kind of proud of the results, although it was rejected. You can see that the correlation is dramatically improved with respect to human compared to all the previous works. So maybe in sooner we will say farewell to rouge and bleu, hopefully. Here it's also a nice figure to show so our matrix doesn't require any reference, so it's stable, but you can see how decreased the correlation for bleu, rouge, or red score with respect to less and less references. And that's the main issue, basically. And yeah, one thing that is really nice is to see that the factual consistency is so well captured by our metric compared to the previous approaches. And this is something extremely important, in my opinion, much more than the improvement for fluency, because we now have models that are quite fluent, but we completely lack of a way to evaluate their consistency. And we know that they tend to have some what we refer as hallucination. And if you want to put a summarizer or translator in production without human to proofread it, that's something you really don't want to not be factual. One really desirable aspect of this metric is that it's more explainable than previous ones. Like, for instance, here you have a source document about, so this is the embarrassing moment a Buckingham Palace guard slipped and fell on a manhole cover in front of 100 shock tourists. So here is an example of question our model generated. Where was the changing of the guard held? Our policy predicted that it's an important question, and the answer span we used to generate the question was Buckingham Palace. So on Buckingham Palace, this is a question and it's an important one. Here, what happens with the correct summary? The Queen's Guard sleep on a manhole cover during. When we ask this question to this summary, the QA model, so we need obviously a QA and a QG model, question generator and question answering systems. The QG generated that. Now that we use a QA to ask this question and this summary. And the previous answer is Buckingham Palace corresponding to the source document. It sounds correct. Now here an example of an hallucinated summary where the Queen got sleep on a manhole at St. James Palace instead of Buckingham Palace. Maybe the model confounded with because Buckingham and St. James was close here. Anyway, the QA model predict correctly that the answer here given this summary is St. James Palace, and this does not correspond to Buckingham Palace. And Another example, quite different here. The summary doesn't mention this fact at all. It's incomplete. It's not hallucinating, it's just incomplete. And so our QA model is able to say it's unanswerable. And so you can see how you can well explain with this metric the results. So before answering the question, if you have, let's conclude and discuss the future work. We show that for the training, the teacher forcing is suffering from important limitations. I believe that leveraging on discriminator is a promising direction, and I am keeping working on that. About the evaluation, I think that first of all, we should have a rule that it's not done on a single language. N-gram-based metrics are poorly reflecting human judgment. And I hope that question-based metrics pave the way for more accurate evaluation. As future work, I'm actually currently working on extending Colgan and DAS with Monte Carlo tree third generation, kind of the AlphaGo of the generation, and combining both. And I'm mostly working on a huge project extending SAFEval with collaboration with Facebook, Google, Adobe Research to make it multilingual, multimodal, and on other tasks such as text simplification, translation, captioning, video captioning, data to text, like generating a description of a table, and multilingual summarization. So we are currently working to extend it for all these tasks, and hopefully we will have results by this summer. Thank you very much for having listening, and I'm there for answering questions.
All right. Thanks a lot, Thomas. It was really extremely interesting stuff. So I think we can start the Q&A session. The first question is from Ramsey, who is asking, thanks, Thomas. Why wasn't multilingual T5 tried out? It might be better for generation as well, I guess.
So sorry, the question is why we didn't try T5 multilingual?
Multilingual, yeah. And it says that it might be better for generation as well.
So actually, at the first answer that at the time we had no T5 multilingual. And so we had no solution, basically. No one was able before T5 or BERT to generate multilingual text. And so our way basically was the only one. Still, I tried recently T5 multilingual, and I have to say, I would think first that it works better. I do agree. But I was quite surprised, and it's not the case. And it's actually extremely slow because they have 150,000 tokens in their vocabulary. And so it's extremely slow and it doesn't give good results. And I'm not the only one having testing it and having this result. It seems not to be that much efficient for now. Still, also what you have to consider that if tomorrow you have a new model better than T5 or anything else that is only an encoder, you can apply the same technique to not and to benefit from the new model for text generation.
All right. So I guess while we wait for other questions, I have one actually. So when you were talking about exposure bias, you discussed about the loss not taking into account, the full sequence, but just token by token. So I was wondering, what do you think about this transformer called ProfitNet, who has this end-stream self-attention and is able to decode more tokens at once. So instead of decoding one token each round, it's decoding more of them. So the loss is actually a weighted average of the decoded future tokens.
I remember I haven't read it in detail, but I think actually the exposure bias was their main motivation, right?
I think so, yeah.
I would say that it seems to work and to be efficient. And if you want results, it might make the job. As a long-term research goal, it's still unsatisfactory because you cannot, for long text generation, you will never be able to have a sequence, real sequence level loss.
Okay.
So I see it more as a trick, basically, to which works, but not solve the problem.
Right. Okay. So don't be shy. Ask questions. Raise your hand. Don't worry. So in the meantime, I was wondering also about the evaluation. So you show that increasing the number of references increases also the quality,
Yeah.
the performance and the metrics. So I was wondering whether one could use some something like a paraphrase generation, or in general artificially increase the number of references automatically, in order to then train the model on more references and perhaps getting better results. Do you think that would work to get higher performances, or perhaps you introduce new errors?
Well, I think I would answer kind of the same than before for Prophet. I mean, as a trick, it might work, even if, although it doesn't solve the thing. But I mean, basically, you are moving the problem from somewhere to paraphrasing. You won't be able to generate all the possible paraphrase. Still, it might allow to improve. I think there's some, I don't have any reference in mind, but there's some nice papers about that, doing synthetic data generation via paraphrasing. I'm not aware of the state of the art for paraphrasing generation. It might be more advanced than, it might be more easy task than, for instance, summarization or translation. If the case, it might be a nice trick to do some data augmentation, in my opinion.
Right, and that in turn could be could increase the performance, right? If you train on this stuff.
Yeah.
If the paraphrase are, of course, of high quality.
Well, I mean, I saw some works. Even if the paraphrase are not that good in terms of quality, it might improve the results. Also, although I haven't seen any work is doing this technique to improve the number of references for the evaluation, which might be something. It could be something interesting to see if using paraphrasing, basically, you can improve blue performance, but with artificial synthetic references.
Right. I think, yeah, the most important thing is just to have a model that produce good paraphrase. Otherwise, you would lower instead of increase the performance.
Yeah, so I think I saw like a lot of work doing that, but not for the evaluation, but for the synthetic training data, doing back translation. Like, we know it's not perfect, but we know that translation is have a high quality now. We have really good translators. And so leveraging on these models with back translation, you can have a decent new data, basically, that you can use to train your model.
All right, thanks. So Ramsey is asking, thanks, Thomas, for the previous answer. Also, what are your ideas, approaches for conditioning text generation, guiding the decoder to generate, let's say, political text, or text generation based on some input keywords, etc., etc., etc.
Yeah. There's a friend of mine that had a really nice paper about that at iClear this year called on controlling stochastic parrots, like in reference to the Google paper, ethical paper about stochastic parrots. But basically, they propose an approach to do exactly that. If you want to control, what about controlling if you want this word to appear in the sequence, or this aspect bias, for gender bias or whatever, and they show their technique works quite well, I think. And what is nice is that it's like you can use multi-constraint to make it work. I haven't tried, but I had this in mind once to extend DAS as a sequential generation driven not by a discriminator, but it could be by any classifier. And you have a paper from Uber Research that do quite similarly, but at inference time only and on multi-constraint like token, classification, sentiment, if you want your text to be positive or negative. I forget the name. I remember there was from Uber Research, but you don't have a lot of papers from Uber Research. So you might find it easily. About, I remember there was these big pictures in their blog post with a mouse and an elephant. So, and basically the idea is that you have a big model like a GPT-3, which is elephant, and their small model like a classifier, bag of word or whatever, they can backpropagate the gradient from this classifier to the GPT at inference time and generate positive, negative, whatever sequence you might.
Yeah, Ramsey is saying CTRL.
Sorry?
Ramsey is saying CTRL, which is, I suppose, the name of the...
Maybe, I don't remember the name. But honestly, in NLP, but from Uber, I don't think
Control.
Yeah, controllable. Yeah, exactly. Yeah, that's it.
Yeah, Ramsey is saying control, yeah.
Yeah, this one.
Cool. So just a couple of points I'm curious about concerning, you know, your DAS approach and using GANs and these kind of things. How, I mean, are they more computationally expensive with respect to the classical generation methods?
Yeah, they are. Well, for DAS, clearly, because you need to run the discriminator in addition of the classifier. For Colgan, well, not that much compared to any reinforcement models. Compared to maximum likelihood and teacher forcing training, yes, but I would say as any reinforcement training, where because you need what consumes the most of the time in reinforcement is that you need to sample sequences. And sampling is an autoregressive process as at inference time, because you don't know the future. And this is why basically it's taking much longer. With transformers and teacher forcing, you can train it in parallel and use in one batch and one computation, you have the loss for all the tokens.
Okay. So another point is that why text rank is biased towards English shouldn't be language agnostic. You know, there you have this like TF-IDF or BM25, whatever that is, but still, right? Should be independent from the language.
So it's a very good question, and indeed, I agree. And our hypothesis is that research, how text rank was built by researchers that it's unsupervised, okay, but it has a loss, it has parameters, and how we determine the threshold for the centrality of a sentence and how far it is from the other, and some parameters like that in the algorithm. This was done by observing the output, obviously, from their model. The researchers applied their model and probably modified the algorithm, as we all do, based on the observation of the output. And if this is done, I believe that if this process is done over a year on a single dataset or a single language, you might actually overfit it. And I think this is my hypothesis. And I believe that, you know, even the tokenization, all our models right now are working based on tokenization. BERT is based on WordPiece. There's a paper that I saw it on Twitter this afternoon for a multilingual paper published at NACL, and they show that it's suboptimal to do the tokenization as we are doing it with byte pair encoding. Basically, it's working well on English, but not on other languages, and it should not be the best solution for multilingual models. And still, we are either for BERT multilingual, T5 multilingual, or whatever multilingual right now, we're mostly doing it with byte pair encoding, because BERT English is doing it like that. So, and why BERT is doing it like that? Because the researchers found that it was improving the quality on English datasets. So it's kind of the same phenomenon, I would say.
Right. Makes sense. Makes perfectly sense. Yes. Cool. So we reached the hour mark. So I guess if there are no other questions, I don't see them here in the chat. Yeah. Okay, cool. So I think we can stop here. So thank you, Thomas, for your very nice, interesting talk. And thanks everyone for having joined us. And yeah, have a nice evening.
Thank you very much, Andrea. Have a good nice evening.
See you next meetup. Ciao.
Ciao. Arrivederci.
Ciao.